All right, so we have a situation here. Let's say there are 18 cookies and 8 kids, and we want to give the cookies out to the kids, and no one can have more than 3. How many ways can we do this? And so, as usual, we want to rephrase this in terms of smaller pieces um, that we understand how to compute. And the broad sort of perspective we want to take is, well, we could just give the cookies out however we felt like. So there's give cookies, right? We can just distribute the cookies however we feel like. But then not all of these distributions are allowable distributions, because some of them would inevitably give more than 3 cookies to some of these kids. So we want to give out the cookies, and then we want to subtract off bad, right? Too many cookies for any kid. All right, so if we want to look at how many ways there are to just give cookies, this is straight up stars and bars, right? There are 18 stars, so to speak. There's 8 kids, so there's 7 dividers. So you're distributing the 18 uh, stars and the 7 bars. So we end up with 25 choose 7 ways to just give the cookies out, right? So that part should be fairly straightforward. And then when it comes to counting the bad cookies, this is a pie problem, or a principle of inclusion and exclusion problem. And let's see why. So you are bad if either kid number 1 gets too many cookies, or kid number 2 gets too many cookies, or kid number 3 gets too many cookies. And so what you're looking at is the union of all of these events. Either kid 1 or kid 2 or kid 3 or kid 4 gets too many cookies, and maybe more than one kid gets too many cookies. That's certainly possible, right? And so we are going to look at what BI is, and BI is going to be kid I gets more than 3 cookies. All right. So briefly for a second, then let's just think about what the size of B, say 1 looks like, and it'll be the same for all of them, but we can just say B1 to make it more concrete. What would it mean for B1 to get more than 3 cookies? Well, we'd have to give B1 4 cookies, right? That way they have more than 3. After that, we can just give out the cookies however we want. Maybe kid 1 gets more cookies as a result, maybe they don't. But either way, if you just start with giving them 4, they have more than 3, so we're bad. B1 is bad, right? So what you do then is you take your 18 cookies, give 4 to B1, leaving you with 14 cookies, still 8 kids, so we end up with 21 choose 7 ways that could happen, right? And this is the same no matter which kid it is, so it's true for all of the B. Maybe I should just say BI then, right? So maybe let's ask ourselves, how big is the intersection of BI and BJ? Let's say kid 1 and kid 2, they both get too many cookies, right? That means you gotta give 4 cookies to kid 1, 4 cookies to kid 2, and that leaves me with, let's say 10 cookies left, right? And then I distribute those however I want. So with that being said, I would get by stars and bars again, there's 17 true 7 ways that can happen. Because now I'm left with 10 cookies, 8 kids, so there's still 10 stars, 7 dividers to split things up. Then next, I have, what if 3 kids get too many cookies? Well, if kid 1, you give 4 to kid 1, 4 to kid 2, 4 to kid 3. That leaves you with 6 cookies left, right? And now you have to distribute the 6 cookies among the 8 remaining kids. So that gives you 13 true 7 ways to do that, right? And then lastly, how many ways could you 4 kids get too many cookies? Well, you take your 18 cookies, you give 4 to kids 1, 2, 3, and 4, or whoever they are, and that's 16 cookies that you give out. That leaves 2 left to give to 8 kids. So that's 9 true 7 ways, right? Now, those are the sizes of how many ways, if I picked an I and a J, like if I picked 1 or 1 and 2 or 1 and 2 and 3, how many ways to give cookies out so that those kids have too many cookies. There's a separate question of how many ways could I have picked the kids to begin with. And so I'm going to denote a different color for this. But if I'm just picking 1 kid, there's 8 kids, I pick 1. There's 8 choose 1 ways to pick the 1 kid. If I'm picking 2 kids, that's 8 choose 2. If I'm picking 3 kids, that's 8 choose 3. If I'm picking 4 kids, that's 8 choose 4. So we finally get down to, well, how big is bad? Well, it's this union of B1 through B8. And so to compute that, I need to go, all right, add up the cardinalities of all the B1s or BIs, subtract off the cardinality of all of the 2 intersections, add on the cardinality of 3 intersections, and subtract off the cardinalities of 4 intersections. And this alternating sum here, that thing is the total number of ways I could distribute cookies that break my rule. So then what I want to do is take my whole total number of ways to give cookies, get rid of the bad ones, and then what I have left is good, proper ways to distribute cookies. Now, let me go ahead and pop something into Desmos real quick here. Let's say I actually want to do this computation. Well, good, I'm going to call that G. Good, we decided was 25 choose 7. And bad is this alternating sum down here where you're starting from 1 all the way up until 4. Let me call this K. You have 8 choose K. And then you have, or you start with 21, and then 17, and then 3, and then 9. So if you're starting at 1, that really is 24 minus 3K choose 7, right? Because when K is 1, 24 minus 3 is 21, and then you're 3 less. Sorry, not 3. You are 4 less. So this should start at 25. So 21, 17, 13, 9. Minus 1 to the K plus 1. Oops, to the K plus 1. And then the final answer was supposed to be the good minus the bad. And so hopefully that was helpful. Thank you very much for watching. As usual, if you have any questions, please let me know. All right, thank you.